Hi, I'm Bob. Welcome to the Stata course on regression analysis and estimation methods. In the previous video, we have learned how to use Stata's post-estimation commands to check whether the model's error term has a constant variance and is normally distributed. We use the residuals and fit values to draw diagnostic plots and do post-estimation tests after running the OLS regression model. We will continue the post-estimation analysis on this topic. We use the course dataset bob.dta. Please download the dataset from the resource link below. The do file for the topic is also provided. We regress the hourly wage on schooling, age, marital status, and gender. Recall that we use the estat hettest command for the heteroscedasticity test on the last topic. The estat command after the OLS regression shows the post-estimation statistics of that regression. Today, we will examine other useful estat commands that can be used after the OLS regression. The name estat can be seen as estimation statistics. We first look at the estat summarize command. The estat summarize command provides a summary table of the variables we use in the OLS regression. We find the sample mean, the standard deviation, the minimum and the maximum value of the outcome variable and the explanatory variables in the model. It will adjust the sample size to that as used in the regression. The sample size here is 4,164. It could be smaller than the sample size when we use the summarize command for the whole dataset. Next, we can check whether there is a multicollinearity problem in the model. We know that if the explanatory variables are highly correlated with each other, the standard errors of the estimates will be large and the estimated coefficients are not precise. There are two commands we can use to check multicollinearity. We first use the estat VIF command. The term VIF stands for variance inflation factor. This command produces a table of information on how much each explanatory variable inflates the variance. In other words, it shows how much each explanatory variable contributes to multicollinearity. The variance inflation factor of a variable is computed using the R-squared from regressing that variable on all other explanatory variables. It indicates how strongly that variable correlates to the other explanatory variables in the model. A variance inflation factor of less than 10 usually implies no multicollinearity problem, as shown in our example. Another Stata command is that VCE displays the variance-covariance matrix of the estimates from the model we just estimated. The term VCE stands for variance-covariance matrix of the estimates. The correlation option specifies that the correlation matrix is displayed. Here we see low correlations between the 4 explanatory variables in the model, and we shouldn't be worried about multicollinearity problem. Finally, we will check whether the model has a specification issue. We can perform the Ramsey reset test by using the command estat ovtest. Ovtest stands for Omitted Variables Test, but it is not about whether some other important variables are omitted from the model. Instead, it is about whether the polynomials of the existing explanatory variables are omitted from the model. That is, whether a square term or an interaction term of the explanatory variables is omitted. It provides information about whether the functional form of the explanatory variables is correctly specified. We type estat ovtest. The null hypothesis is that the model has no omitted functional forms of the existing explanatory variables. The F statistic is 19.44 with a p-value of 0 to 4 decimal places. We reject the null hypothesis at any reasonable significance level. It suggests that we should include the square terms or the interaction terms of the explanatory variables in the OLS regression model. Today, we have learned a series of the estat commands after estimating an OLS regression model. They help us find summary statistics of the variables used in the model and test for whether the model has a multicollinearity problem or omitted functional forms of the existing explanatory variables. Thank you for watching this video. See you tomorrow on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.